Okay, so can you tell me about yourself and your recent project?
Yeah, sure. So thank you for giving me this opportunity. I have around 3.8 years of experience in software development and primarily working with Java, Spring Boot, and microservices. And I completed my bachelor's degree in computer science in 2021, and after that I joined Cognizant, where I have been working since then. And during my career, I have mainly worked in the telecom domain. So in my initial projects, I got exposure to maintain and enhancing existing applications, and gradually I moved into developing microservices based applications. So along with that, I have worked with technologies like REST APIs, JPA, Hibernate, MySQL, Maven, Git, Basic Cloud, and CI/CD practices. Talking to about my recent project, so I was involved in migrating project where we were modernizing a legacy Java application and moving it to the microservices architecture. So actually the older application was tightly coupled and built using the traditional approaches. So the basically the objective was to improve the scalability and maintainability and also the deployment flexibility of that project. So yeah, so in this project my responsibilities mostly like included in the developing the REST APIs in Spring Boot, implementing business logic, integrating with databases, and fixing the production issues as well. So apart from that, I have also participated in the analysis of the project development plan. So since multiple teams were involved in that, so there were lots of discussions around like service boundaries and database design and backend compatibility. So I have been involved in all that. So yeah, so this is what is about me and
Okay, so
my
can you
recent project.
explain any one microservices that you have developed from scratch, like from end to end?
Yeah, so one microservices that I worked on from scratch was like the customer notification service, for example, in our telecom project. So basically, the purpose of this service was to send notifications to customer whenever there was an important event, such as like kind of plan activation or recharge success or any kind of status update. So in that, I was basically involved in the complete development life cycle of the microservices. So initially, we had like requirement discussion with the business team to understand the notification flow, and we also discussed whatever the expected response formats we have, and based on those discussions, we designed the REST API and prepared the API contracts. After that, I created the Spring Boot project structure and implemented the controller, service, and repository layers following the standard design practices. And for database operations, we used like Spring Data JPA and MySQL, and I was basically responsible for creating the required entities and repository methods. The service used to receive the request from one microservice through the REST APIs. So once a request came in, then we validated the input and then applied the business logic on top of that. And after that, we stored the notification detail in the database and then triggered the appropriate notification channel to further send that notification back to the whatever the clients were there. So while development of this, we used various things like we had global exception handling. For example, we have add the rate of controller advice. So we added that in order to handle the global exception. And apart from that, the Swagger documentation was also integrated so that like other teams could easily understand and consume our APIs. And after development, I have also participated in code reviews and fixed defects and identifying the all the defects during testing and fixing them also. And after that, again, once the service moved to production, then I also helped like investigated the issues by analyzing the logs and coordinating with the independent teams. Like whenever required. So yeah, so overall, like this microservices, I got a good exposure of end-to-end development, and right now, like it has been already deployed to production. So yeah.
Okay, fine. So can you tell me if the constructor can be final, static, or abstract?
So yeah, no, the constructor cannot be final, static, or abstract. So a constructor cannot be final because like constructor are more like it is not inherited by child classes. So there is no concept of overriding them, right? And it cannot also be the static because the constructor is used to initialize an object, and a static members belong to the class rather than the particular instance. That is why it cannot be static also, and also it cannot be abstract because abstract methods are meant to be like implemented by subclasses, whereas the constructor are neither inherited or not overridden. So yeah, so that's the reason it cannot be any of this.
Okay, so if a constructor cannot be static, then how do static blocks work?
Static block and constructor are two different things basically. So constructor so static blocks are executed when the class is loaded into memory and are used to initialize static data, but constructors are executed when an object is created. So yeah, so both are two, I mean, different things.
And how about can it be private?
Constructor private, yeah, it can be private. So private constructors are used to restrict object creation from the outside of the class basically. So for example, the singleton design pattern is there, right? So there we use that. So yeah, so it can be private actually.
Okay, so how do you create the singleton design pattern?
Yeah, sure. So like singleton design pattern is used basically when we want only one instance of a class throughout the application. So basically to create the singleton class, we first make the constructor private so that no other class can create its object using the new keyword. After that, like then we create a private static instance of that class, and after that again, like we provide a public static method. So that generally that is like called get instance. We use that. So that basically returns the same instance whenever it is called. So it does not have to create again and again. And again, if the application is multi-threaded, then we also need to make the like implementations thread safe. So we can achieve that using like synchronized methods and double checking locking. So yeah, so we can use these, and even we can use enum based singleton implementation also. So that is also a good like better option. So yeah.
Okay, so if a class has a static block and a constructor, then what is the execution order when two objects are created?
Yeah, so execution order like a static block executes when the class is loaded. So then it will be static block, and constructor executes whenever the object is created. So yeah, so it depends on like which one we are trying to achieve
Okay,
first.
so what happens if a static block throws an unchecked exception?
Yeah, if a static block throws an unchecked exception, then the class initialization fails and the JVM throws an exception initialization error. So as a result, the class cannot be loaded properly and we won't be able to create objects of that class or access its static members. So for example, let's say if we have some code inside the static block that let's say causes an arithmetic exception or maybe null pointer exception, then that exception gets wrapped inside that like exception initialization initializer error. Okay, so that gets wrapped during the class loading. So yeah, so that's how it is getting wrapped.
Okay, so if the class initialization fails once, okay, so what happens when you try to use the class again?
Yeah, the JVM marks the class initialization as failed, and if any subsequent attempt is being made, then it will result, I think, no class definition found error. Yeah.
Okay, can you tell me why hash map is not thread safe?
Yeah, HashMap is not thread safe because it is not designed to handle the like concurrent access by multiple threads. So actually, it does not use any synchronization internally. So if like multiple threads try to modify the hash map at the same time, then it can lead to kind of inconsistent data or like unexpected behavior. Okay, so any kind of operation like maybe put or uh, like we have put method, right? So that are not atomic. Okay, so for example, while one thread is resizing the hash map, and another thread may also try to insert data, so that can cause data corruption. So that is why like a hash map is generally like I mean used in the single thread environment. So yeah.
Okay, and how about the reading of hash map? Is it thread safe?
Yeah, if the hash map is completely initialized and no thread is modifying it, then concurrent reads are, I mean, fine. But if suppose that read and write is happening simultaneously, then it is not thread safe. But we cannot guarantee that it is thread safe.
Okay, and is it good to use collections.synchronized map? We can use this directly, right?
We can use it, but it we try to use whenever possible like concurrent hash map. So we can use it, but it synchronizes the entire map actually. This collections dot synchronized map, and this allows only one thread to access at a time. Okay, but when suppose we are using concurrent hash map, then it provides the better scalability because it allows higher concurrency. So yeah, so it's better to use concurrent hash map instead of that. Yeah.
Okay, so can you tell me how does concurrent hash map handle concurrency differently in Java 7 and Java 8? So what is the difference?
Yeah, so the internal implementation of concurrent hash map changed significantly. Yeah, from Java 7 to Java 8, that is true. So in Java 7, like earlier version, like concurrent hash map used a concept called like segment level locking. So the map was divided into like multiple segments, and each segment had its own lock. So by default, there were 16 segments, and that meant that like 16 threads could perform write operations simultaneously on a different segment. Okay. However, from in Java 8, like this segment approach was removed to improve the performance and reduce the memory overhead. So instead of using it, it uses like CAS. There is a concept, so compare and swap operation for most updates. Okay, so if synchronization is required, then it locks only the specific bucket or bean that is being like modified rather than this larger segment. So yeah, so because of this, like Java 8 concurrent hash map provides better concurrency and scalability compared to the Java 7. So yeah.
Okay, and what is this CAS exactly? Compare and swap?
Yeah, so CS like it is non-blocking atomic operation we can say. So it first like kind of checks whether a variable contains the expected value, and if it does, then it updates it. Okay, and in if another thread has already modified the value, then the operation fails and retries. So that is the concept of it.
Okay, so what is the difference between comparable and comparator?
Yeah, both comparable and comparator are used for sorting in Java, but the main difference is where and how to define the sorting logic. So that is the main difference. So actually the comparable is used when a class has a single natural sorting order. So in this case, the class itself implements the comparable interface and overrides the compare to method. Okay, so for example, if we always want to sort like employee based on their employee ID, okay, then we can implement comparable inside the employee class. Okay, on the other hand, like comparator is used when we need like multiple sorting strategies. Okay, so we are not going to sort only based on employee ID. Sometimes we can sort based on employee ID, sometimes we can sort based on the maybe a salary, maybe based on age. Then we have to use the comparator instead of comparable. So it is implemented outside the class by overriding the compare method. So for example, for same employee class can have different properties, right? So yeah, so comparable basically provides a single default sorting mechanism, whereas comparator provides the flexible and multi-sorting options. So that's the difference.
Okay, so in that case, why not to use comparator itself always?
Yeah, so actually technically we can always use comparator, that is true. In fact, comparator is like kind of more flexible because it allows multiple sorting strategies without modifying the original class. Okay. However, if a class has a clear natural ordering, using the comparable makes like more like intention and and explicit. Okay, so it tells everyone that like this is a default way, and like in this way, like object of the class should be sorted. So for example, like let's say we have employee class and the business says that employees are like naturally ordered by the employee ID always, then implementing comparable makes sense. But if the sorting criteria is keep changing with the requirement, then we have to use a comparator. So yeah, so it's not that we cannot use always comparator, but the choice depends on whether the class has the well-defined natural ordering or multiple sorting requirements.
So performance or memory wise, you see any difference?
Usually, I think there is no significant difference, but comparable can be, I think, very slightly faster because the comparison logic is the part of object itself. So with comparator, an additional comparator object is involved, an extra method call is made. So that's the main difference, right? But in real world application, this difference is kind of negligible and usually not a deciding factor like which one we have to use. So it is very minor difference, but yeah.
Okay. So suppose we have the code like we have the wrapper integer class, okay, and we say integer a equal to 100 and b equal to 100, okay. Now when we say a double equal to b, then what will be the output? And also tell me when we have c equal to 200 and d equal to 200, and then when we say c double equal to d, then what will be the output?
Uh, so once we are comparing a equal to 100, so 100 and b equal to 100, and now again we are comparing c equal to 200 and d equal to 200, right?
Yes.
Yeah, so like in Java, double equal to compares the reference for objects, whereas equals compares the values. So for integer objects, Java maintains an integer cache for the values ranging from -128 to 127. Okay, so when we write like integer like 100, when we are going to compare with 100, like a equal to 100 and b equal to 100, then it will return true. Okay, because it is within the range of the that cast value. Okay, however, when we say like c equal to, let's say, 200 and d equal to 200, so in that case it will return false. Okay, so like when comparing wrapper objects, like it's generally recommended to use equals instead of a double equal to, because of this reason. So yeah, so if you are doing the double equal to, it will return false, but if we were doing the equals method, then it was going to return the true. So yeah.
Okay, and what is the use of maintaining this cache?
Yeah, to improve the performance and reduce the memory uses. That's the main reason, I think. So small integer values are usually very frequently, like so reusing the existing object avoids unnecessary object creation. So yeah, so that's the reason.
Okay, so is this caching applicable only to integer or other wrapper classes also?
No, other wrapper classes also, like byte, short, long, character, and boolean. So they also maintains the caches. Okay, so although the range is different, but they all have the caching.
Okay, fine. So can you tell me what is the difference between map and flat map?
Yeah, both map and flat map are like intermediate operations in Java streams, but map we use when we want to transform each element of the stream into another element. Okay, and flat map is used when each element itself contains multiple elements and we want to flatten them into single stream, right? So then we can use flat map. So map, like kind of, we can say it performs a one-to-one transformation, whereas flat map performs a one-to-many transformations, and ultimately it flattens the result. So that's the difference.
Okay, and can you tell me the quick example?
Yeah, so like suppose we say like arrays dot as list, okay, and inside that, let's say we have like two three strings are there. Let's say maybe a b c x y z and maybe something, okay, and then let's say we say list dot stream and then map, and then we just say like we just transform it like a string to uppercase, okay, and then we can say collectors dot to list. So it will just transform the existing list to the uppercase. Now again, let's say we have another scenario. Again, we say like arrays dot as list, and again inside that we have nested like arrays dot as list, and we have some strings, and again comma arrays dot as list, again some other strings. Now we want to flatten, means we want to keep all of them into the same page. Like we want like that string 1, string 2, string 3, string 4, all 4 into like to be flattened and so into the same part of array or something. Okay, so in that case we can use like flat map.
Okay, so in Java 8, can an interface having default methods still can be the functional interface?
Yeah, an interface can still be the functional interface even if it has default or static methods. So basically the condition is the only condition is that it should have exactly one abstract method. Okay, so the default methods and static methods are not counted while determining whether an interface is a functional interface. So as long as there is only one abstract method, the interface remains a functional interface. So yeah.
Okay, so let's say we have a interface test, okay, and inside that we have, let's say, void method 1, and again we have void method 2. So two abstract methods are there. So what will happen?
Yeah, so yeah, it will throw error, compilation error. It will throw. So it will throw compilation error like only if if we are using add rate of functional interface on top of that interface test. Okay, so in that case it will throw the compilation error because we are telling that this interface is a functional interface, not normal interface.
Okay, so what are the built-in functional interfaces you are aware of?
Yeah, there are many like runnable, callable, and then consumer, supplier, predicate, function. Yeah, so all these are there.
Okay, and what is the use of these inbuilt functional interfaces?
Yeah, they all have their own purpose. So, for example, we have predicate. So, the predicate is used when we want to test a condition and return like true or false. Okay, so it is like Boolean. Boolean test we can give and it just returns true and false. Okay, so we can use that in that case. And coming to consumer, like consumer takes an input and performs an operation without returning anything. So that's the consumer. So like it just have signature like void accept, and we have like T. So
Okay, so can you tell me just one example of predicate where you have used?
yeah, so like let's say for example we have let's say list of names. Okay, so let's say we have list of names, and then we say like names dot stream dot filter, and when we use lambda expression like name and then name starts with let's say A. Okay, and then we apply for each, and we are just doing let's say system out dot println. So here the names dot start with A. So that is the predicate actually.
Okay, so how this is predicate? So you are saying that name starts with A is predicate, right? But the signature you told like Boolean test, how you compare these two things?
Yeah, so basically, the predicate signature is that is true Boolean test, but it is with being used with Lambda, right? So in Lambda, we know that like let's go for the okay, let's go with the predicate definition. Okay, so in predicate, it is a functional interface, right? And it will have exactly one method, right? Maybe a Boolean test. Okay, so we don't have to define the name of the interface here when we are going to use Lambda, right? So Lambda is basically just a shorthand of implementing the single abstract method. Okay, so like when we say string name and then Lambda return name that starts with a, so we don't have to write everything, so we can just say name then Lambda expression like minus and greater than symbol and name that starts with a. Okay, so it we can use directly that one, so we don't have to write the whole thing. So yeah, so that's the reason we are using Lambda here. So that is how it looks like this. Yeah.
Okay, so why do you think that at the rate of functional interface is optional?
Yeah, so yes, the function interface is optional. It is not mandatory. So even if we don't use this annotation, the interface will still behave as a functional interface as long as it contains the exactly one abstract method. So actually, the main purpose of functional interface annotation is to provide the compile time validation. So it acts like a like kind of safeguard we can say. So if someone accidentally adds like maybe another abstract method in the future, then the compiler immediately throws an error. Okay, so that's the main purpose of using it.
Okay, can you tell me what is the difference between add component, add service, and add repository annotation?
Yeah, so they all are stereotype annotation in Springs, and ultimately all of them like create Spring managed beans. But the difference is like main in their like purpose why we are using that. So add component is like most generic annotation we can say. So we use it when a class does not especially belong to the service or a persistent layer, and add service is generally like used for the classes containing the business logic. Okay, so and the repository we is used for the like persistent layer such as DOL classes interacting with databases and all. Yeah, so this is what is the main difference between these three.
Okay, and can we interchange these annotations?
Yes, technically we can interchange them most cases because like at that of service repository and controller are all like a specialization of component only. So Spring will still detect them during component scanning and register them as a beans. Okay. However, from a design and maintainability perspective, we should use the appropriate annotations wherever it is meant to be used. Okay, so however, there is one major difference we can notice, like whenever suppose at the repository level we are suppose let's say we use add date of service on the repository class, so in that case we lose the exception translation feature provided by the add repository. So that's the major difference actually. Otherwise rest of them can be used, but yeah, it is suggested that we should use the annotations at the appropriate places.
Okay, can you tell me what is the difference between field setter and constructor injection?
Yeah, so like Spring mainly supports three types of dependency injections. So these are those. And in field injection, like dependencies are injected directly into the fields using like we can use add date of auto add. Okay. And setter injection is like that uses setter methods to inject the dependencies, and constructor injection injects the dependencies through the constructor of the class. So that's the I mean main difference between these three. And we prefer like constructor injection most because like it prompts immutability and makes like unit testing easier, and also ensures that like mandatory dependencies are provided at object creation time. So that's the main difference.
Okay, so can you tell me how do you validate request payloads?
Yeah, so we use like validations notations like at the rate of not null, at the rate of email, at the rate of size, and along with at the rate of valid in the controller methods. So we can use these actually to validate the payloads.
Okay, so can you tell me what are the advantages and challenges of microservices architecture?
Yeah, microservices allows us to break a large monolithic application into smaller independently deployable services. So each service can be developed, deployed, and scaled independently. So that improves the team productivity and release agility. So in microservices, like we are free to choose any kind of tools and technologies. Maybe one of the microservice will be using the Java, another will be using Python or .NET or any kind of databases also. So everything is flexible. So that's the main advantage of it. However, microservices also introduce distributed system complexities such as like inter-service communication, monitoring, distributed transaction and debugging. So these are like little bit complex. So however, we have the ways to handle these also. So I would say like these are challenges also we have. So yeah, so that's the main advantages and disadvantages we have.
Okay, and how do you handle communication between microservices?
Yeah, microservices can communicate synchronously or asynchronously depending on the business requirements. So for immediate response, we can use like maybe REST APIs through Fin client. For example, an order service is calling an inventory service to validate a stock availability, then we can use that. Okay, and for event driven scenarios we can prefer like Kafka because like it depends on the producer and consumer. So for example, after an order is placed, then multiple services such as like notification, analytics, and loyalty can react like independently to the same event. So that's the biggest ways we can use. Yeah.
Okay, and what is the main difference between Fin client, REST client, and web client?
Yeah, REST template basically was like that is a traditional way to making the HTTP calls in Spring. but it follows a synchronous blocking model and is now like we can say like it is maintenance mode. I mean rarely we use them. And fin client provides a declarative approach, so we simply define an interface and Spring generates the implementation and makes the code cleaner and easier to maintain. Then coming to web client, so that is the part of Spring Web Flux and that supports the non-blocking reactive communication. So it is suitable for the like high concurrency applications where efficient resources utilization is like more important. So that's the main difference between these three.
Okay, and what is service discovery and why do we need it?
Yeah, so in microservices, instances can scale up and down dynamically, especially in cloud environments. So because of this, like hard coding service URLs is not practical. So now service discovery comes into picture. So that allows the services to register themselves and discover other services dynamically. So tools like we have Eureka and Consul, so they are commonly used for for this purpose. And when a service starts, then it registers itself with the discovery server, and other services query the register to locate it. Okay, so yeah, so that's the purpose of the using the service discovery.
And what is distributed tracing?
Yeah, distributed tracing helps us to track a request as it like travels through multiple microservices. So, or in monolithic application, like debugging is kind of straightforward, but in microservices, a single request may touch several services. Okay, so like we have tools like Cloud, Jipkin is there, and then other tools are also there. So they allow us to visualize the complete request journey. Okay, so like let's say for example, if an API response is let's say taking 10 seconds, so tracing will help like to identify like exactly which service contributed to the delay. So which service took how many seconds and which one took more time. So this significantly reduces the troubleshooting time and improves the like observability in production system. So yeah, so that's what is the distributed tracing is.
Okay, and can two microservices share the same database?
Two microservices same database, technically yeah, so they can, but in like that is generally not recommended. Okay, so one of the core principle of the microservices is that like each service owns its own data. Okay, so sharing a database creates like kind of tight coupling. Again, we are going away from the microservices concept. Okay, so we are going towards the monolithic thing. Okay, so like independent deployment and scalability also may become difficult because of this. So yeah, in practice, like each service should have its own database and communicate through the APIs or events. So yeah, so shared databases are sometimes used during the migration phase, but it's long-term strategy. Like it is not considered for that. Yeah.
Okay, and what is Kubernetes and why it is used?
Yeah, Kubernetes is the container orchestration platform. So that is used to deploy, scale, and manage the containerized application. So it like automates tasks such as like service discovery, load balancing, self healing, and rolling updates. So yeah, so for example, if a production crashes, then Kubernetes automatically replaces it, and it also allows like horizontal scaling during the traffic spikes. Okay, so in microservices environments like Kubernetes significantly simplifies the operation management. So that's the Kubernetes is, yeah.
And what is CI/CD?
Yeah, CI/CD like it stands for continuous integration and continuous delivery or deployment. So continuous integration ensures like code changes are frequently managed and validated through the automated builds and test. And continuous delivery automates the release process. So like applications are always deployment ready. Okay, so this reduces the manual effort and accelerates like releases and improves the software quality. Okay, so in our project like CI/CD pipelines, we like that has helped us very much. So we use it for the release changes with greater confidence and consistency.
Okay, and what is the difference between horizontal and vertical scaling?
Yeah, vertical scaling means like increasing the resources like CPU and memory on an existing server itself. Okay, so like we have monolithic application, so usually it is used for them. So and horizontal scaling means adding more instances of the application. So microservices are generally designed for the horizontal scaling because like it offers better fault tolerance and flexibility. So that's the horizontal scaling. So if one instance fails, then traffic can be redirected to another one. So that's why we say like it is the horizontal scaling.
Okay, so in database, can you tell me what is the difference between delete, truncate, and drop?
Yeah, so delete removes the rows from the table and supports like the where clause. So that allows the selective deletion. Okay, and truncate removes all rows from the table without where clause. Okay, so that's the main difference. And drop completely removes the table structure along with its data. So that's the main difference between these three.
And what is normalization? Any idea?
Yeah, normalization is the process of organizing data to reduce redundancy and improve the consistency. So the most commonly discussed we have one NF, two NF, three NF and all. So like it helps like eliminate duplicate data and update anomalies. Okay, so that's the main use of normalization. However, like excessive use of normalization may require multiple joins. So in performance critical system, like some level of denormalization may also be considered. So
Okay, and what are the transaction isolation levels?
yeah, so isolation levels determine how concurrent transaction interact with each other. So common levels include read uncommitted, read committed, and then serializable. So all these are the common levels. So higher isolation improves the consistency but may reduce the concurrency. So in most enterprise applications, like read committed is commonly used because like it balances the consistency and performance. So the appropriate level depends on the business requirements actually. So that's the transaction isolation levels.
Okay, and do you know optimistic locking and pessimistic locking?
Yeah, optimistic locking assumes conflicts are rare and checks whether data has changed before updating it, and often using a version column. Okay, and pessimistic locking assumes conflicts are likely and locks the data during the processing. So that's the main difference. And optimistic locking basically provides the better scalability and is commonly used in web applications. And pessimistic locking is preferred when the data conflicts are frequent and must be like prevented immediately.